Hey everyone, I'm trying a wild and crazy attempt at using my computer to record my videos. So I thought I'd do finding the minimum spanning tree example. So to find a minimum spanning tree, don't forget that you need to visit each one of your vertices. So you have to visit all your vertices. So you have to visit each one of these vertices while being mindful of the weight of the path that you're traveling. So there would be your weight right there. And we're going to need to make sure to be mindful of that. So I'll just clean up my mess a little bit. So I'm going to start here at vertex number A. Once visited, I'll circle them with green. So that way we know that we visited. So we'll start here at vertex A. So that's our starting point. Start right here. And so what you're going to want to do is you're going to want to look at the different possibilities that there are to travel away from A. So we've got a weight of 2 here, we've got a weight of 5 here, and we've got a weight of 6 here. So really you want to be looking at starting at the minimum number, the smallest number. So if you're given a choice between 2, 5, and 6, obviously you're going to want to pick this path to start. So I'll make that a little bit more clear. Just make that red. And so there's our first path we'll take right there. We've now been able to visit A and B. So we've got A taken care of, and we've got B taken care of. So we've got those two vertices taken care of. Next thing we're going to do is we can look at the different possibilities we have from the two vertices we have in front of us. So we're going to look at both A and B. We've got traveling to C, which would get us a vertice of 8, or sorry, along the edge of 8. And we can look at going from B to D along, that would be about a value of 6. And we could go from A to D, which would take us a value of 5, and then A to F, which would be a value of 6. Again, you take the lowest option. The lowest option here is 5. So what we're going to do is we'll then draw our path that we've taken. We now know we visited D. So we want to get to C. We know we can get to C by B, so we can get to there by here by going from B to C, which would be a value of 8. I don't think that's our best choice. When we can get there by D, that gets us up to C, and C is checked off. So all we have left to visit now is E and F. So we can look at some different options. We can look at getting to F, which would take us a value of 6 directly from A, which is a possibility. We can look there, getting there from D, which is a value of 7. We can also get to F by E, which is only a value of 2, which is a really low value. When we look over, we can also get to E really easily through C, or by C, which is only a value of 5. And when you look around, that's probably your lowest value. So I'm going to select to go from C to E by 5, which is way lower value than going to E by D, which would be a value of 6. And then finally I'll connect E to F, getting that. And then you have to figure out the total value. So let's say, for example, this was the cost of connecting fiber optic cable from each one of these locations. So if the cost was to figure out how much fiber optic cable it cost, and each one of these numbers represented the value in thousands of dollars, so that you could then figure out the cost. So we would take 2, add 5, so that's this value right there. We've now taken care of the 5 right here. Next we'll get the 3, which is connecting D to C. Next we'll get this 5 taken care of, so that's going to be plus 5. And then our last value that we've not taken care of is 2. And I know that 5 plus 5 gets me 10. I'll just get a different color just so I can show you what's happening in my head. I know that 5 and 5 is 10. I know that 3 and 2 is 5. If you use your calculator, it's also fine. So 10 plus 5 is 15, plus 2 gets us a grand total of 17, so that'd be $17,000 would be the lowest cost of connecting all these different locations. So that gets us to 17. There's another way to do this question. Now let's pull this up really quick. So there's another way to do this. If you're thinking, oh, that was too quick, there's our final answer. Sorry, I'll let you pause it if you need to take a look at that. Another way to do this question is using something called Pym's algorithm. So again, you just have to pick any vertex that you want to. So I'm going to pick A again just as my starting point. So I'm going to pick A as my vertex. So with Pym's algorithm, you start by listing all the possible vertexes that you could connect to and the weighted values. So you'd write bracket A comma B. My writing is so neat. It's like beautiful. Should I add a mouse or something? Or even like a writing pad or something. Oh, I can use my finger. I forgot about that. Okay, AB equals the value from A to B is 2. So then the next value we can do is from A to D. I've forgotten about using my hand, not the mouse. A to D is 5. And then finally we can also figure out what it's from A to comma A to F. There we go. A to comma F. And A to F is 6. So then you know, because you must pick the smallest value, this is the smallest connector. So you've then figured out your first location. So now you need to look at the vertices A and B because they are now part of your choices. So now you're going to look at A and B because they're in our choice range. We are now going to list all the possible vertices for our next decision. So we have just checked off this path. So we've just said, yeah, that's one of our paths. So next we got to list all the possible paths from A to B and figure out what our next one's going to be. So I'll just grab a blue. I'll work down here. I'm going to run out of room pretty quick. So we've got B to C. That equals 8. We've got B to D. That equals B to D 6. We've got A to D, which equals 5. And we've got A to F. It's just a little bit of more organized method than what I just showed you, which is 6. You then select the small, I'm just making sure I visited all the possibilities that are possible. You then select the lowest value of them all. You then circle it that we know it. You can include it in your diagram to draw it. So now we got D. So now we repeat. You list every possibility for A, B, and D, and you select the lowest value. So again, we can then continue on this. I'll do this up in the top hand corner here. I'll pick another different color. We'll go with purple. Okay, so we've got B to C, which is 8. We've got D to C, which is 3. I forgot to close my brackets. Sorry if that was a little bit messy. We've got B to D, which is 6. My screen just wiggles as I do this. We've got D to F, and that is 7. And we have A to F, and that gives me 6. Again, you then take the lowest value of them all. D to C is our lowest value. You connect the line. And you can see I'm coming up with the same result as I would have before. We would repeat again to then get to E and F, and you really can start narrowing it down because we don't really need to repeat it all. We just need to figure out all the different ways to get to E, and then that would be from both D and C because we've connected to those dots. And then finally, you could then figure out all the different ways to get to F, and you get the exact same path. So it's another way of finding the minimum spanning tree using Pym's algorithm. So this method is using Pym's algorithm, and this is kind of a visual way that's a little bit less organized, but if you can kind of do it by comparison, it also works. I hope this worked for you. I'm pretty happy with the quality. I'm going to check it out and replay it to myself. But I hope this was good, and I hope that you're all doing well and staying safe. Take care. Bye.